Hello, this is Rochelle, and in this video we're going to talk about finding the equation of a line if we're given a graph. We've already talked about how to find the equation of a line given 2 points or 1 point and the slope. And so we're really in this video going to be focused on this y equals mx plus b form. And if you recall, the slope is m, which is also we consider rise over run, or the difference in the y values over the difference in the x values. Wow, you guys have to put up with my horrible writing. The b value, 0b, is my y-intercept. So we're going to take that into consideration a lot when we are trying to find the equation of these lines. So if we look at our first graph here, trying to just move up. Here we have a graph that is based on a person's income versus the number of hours that they've worked. And so realistically, if we want to find the equation of this line, I notice right away that my y-intercept is 0. Okay, so right away I know that when I have this is going to be 0 right here. The next step is I need to figure out what the slope is. So if we look at what we have drawn right here, this vertical line right here, this is the difference in my y values or my rise. And this, what I have in red here, is the difference in my x values. Wow, I'm going to make x's a little bit funny there. Or my run. So what our job is really, when we're writing our equation here, this is going to be plus 0, is to put that rise over that run. So we can take the 2 points and do this subtraction, but we can also try to measure it by looking at the graph, because I can see here it's going from 30, and then it's about knowing what this value is on how far it's going up. So it says it's going up by 15, so I guess this height is 15, right? And then this width, which I know I can see right here, this width in red is just a difference of 1. So that's where I could see that it's 15 over 1. I should have put that in green. I apologize for that, for my slope. So let's go ahead and look at this in an actual example where we're not given the slope. Excuse me. So we want to find this. Here we have income. Is this the same exact graph? Yep. So what I would do if I were looking at this graph is I would recognize that my y-intercept is 0 right away. Now to find my rise, what I would do is I would identify points that I could actually see. So this goes through the point 2, 30, and then this goes through, where the axes are crossing here. So what I would do is I would try and figure out what this height is. And basically, it's just a measurement between here and here. And this goes 30 to 40, 40 to 50, 50 to 60. So that height is 30. So my height is just going to be 30 here. My width between these 2 points right here, my width, if I look right here, it just goes between 2 and 4. That width is just 2. So I can look at the graph and find my equation. Now, when in doubt, if you get a little bit confused, you can always go ahead and take these points. Wait, this is the point 4, 60, and then 2, 30, and go through the process that we went through on finding the equation of the line between 2 points by finding the slope and then plugging it into either point slope or slope intercept form. So we're really going to focus on trying not to do that. So my first job, I think, is to really identify my y-intercept. And so the scale is written really small on this graph. So let's go ahead and make it a little bit bigger. You will notice here that my y-intercept is happening at 4. So that automatically means that my y-intercept is going to be 4. So now all I have to do is I have to identify my slope. So to identify my slope, again, I am going to try and calculate the rise and the run. Now I need to pick some points that go through a value. So I'm just going to pick a couple points at random. Like I see this point. I also see this point. I want to show you that the rise over the run will be the same no matter which 2 points we pick. We've got lots of points here. So if I pick this point right here and this point, again, I'm kind of trying to figure out what my rise is and what my run is between those 2 points. I could have also drawn it here and here. So it all depends on how I look at it. I'm going to think of it, if I want to go from this point, this is my first point, to this next point, this is my second point, I'm going to need to go down. So I'm going to draw an arrow here. I went down 1. So that means my rise is -1 because I'm going down 1. And then I'm going to go to the right 2 units. So I'm going to put my arrow here and I'm going to the right 2 units. And that tells me that my slope is -1/2. Well, even if I picked the endpoints here, I would come up with the same value. So I'm going to consider this my first point. If I go to get down to this point over here, I'm going to have to go down all this way, down 4 units. And then I'm going to have to go to the right all the way over here. And this is at 8. So I'm going to have to go to the right 8. Well, that slope would be -4 over 8, which ends up being -1/2. Just to point out, oh gosh, I drew the wrong colors. If I considered this 1 point, I could think of it as going from this point, which would be up 1, but then to the left 2. So that slope would be up 1, so it'd be +1, but to the left would be negative. That's still going to give me my slope of -1/2. So let's look at one more example here. Oh, I guess I have 2 more examples. And that is here, I have just a horizontal line. I see that my y-intercept is at 3. Now, whenever I have a horizontal line, if I take 2 points, my run is definitely 1, but my rise, I don't go up anywhere. I just go over. So it's 0 over 1. So this slope is just going to be 0 right here, which is going to give me the equation just y = 3. So a horizontal line is always going to have the equation y = a number, whereas a vertical line will always have the equation x = a number, whatever that number happens to be. So if it's at 4, it'd be x = 4. So let's do one more. And this one is challenging because if you look at it, my y-intercept is at a fraction value. Wow. Oh, look. X would be -2 here because it's a vertical line. But so my y-intercept is a little bit harder to find. So in this case, it looks like it's at -1/2, but if I'm not sure, then I'm going to go ahead and I'm going to find 2 points on the graph, and I'm going to try and find my slope. Again, if you get confused, you can always just find these points. Oops, I'm sorry, I wrote the wrong thing there. This would be 1, -2. And you can go ahead and find the equation of the line between those 2 points. You don't even have to look at the graph. But I'm going to look at the graph, and I'm going to see my rise and my run. So to go from one point to the other, I went down 3, and I went to the right 2. So my slope is going to be -3. To the right 2 would be positive. So my slope is just -3/2. Now again, I could approximate this, but if I wanted to check and make sure I was right, then at that point, I would need to either, oh goodness gracious, either plug this into this formula or plug it into my y minus y1 equals -3/2 times x minus x1. So this is the slope-intercept form, and this is point slope. To verify what my b value is, I would need to plug in one of these points. So I'm just going to choose this first one here. So I plug in -1 and 1. I would still have -3/2 here. And if I added 3/2 to both sides and I used my calculator to do my addition, I would see that this is going to end up being 1/2. If I do it this way and I plug in my point here, so I'm going to plug in my y value right there and my x value right here, I'm going to get the same answer because I'm going to have -3/2. This would be x plus 1 because two negatives are going to equal a positive. I would distribute the 3/2 through. And then I would need to add 1 to both sides, which is exactly what I did over here. And I would end up with -3/2 x minus 1/2. So my final step over here would be to write my equation. And that's how we find the equation of a line given a graph.